Hello everyone, myself PIYUSH and TANDEL, working as Assistant Professor in Electrical Engineering Department of Mahatma Gandhi Institute of Technical Education and Research Center, Navsari. And the name of subject is Power System Planning and Design, which comes in 4th year, 8th semester. Right now we are discussing the chapter number 1, that is Transmission Line Design, and this is the module number 1.7. So in this module we are going to see the mechanical design of transmission line. So support over mechanical line. So our electrical transmission line is support over mechanical line, that is the mechanical towers. So in this video we are going to see, or we can say we are going to study about different types of towers. So in overhead transmission system, the conductor should be run above the ground from one place to other. Line support are used for this, that is called as a poles or transmission towers, and insulator are kept on the cross arm fitted to pole or steel towers. Okay, so insulated is going to isolate the live conductor to the towers, and live wires are tied on the insulators. Then line support are made of wood, RCC or steels. Okay, so these are three different types of material which we are going to use for making our transmission towers. Here we shall obtain information about construction of different type of line supports and their relative advantage and disadvantages. So now we are going to see some of the property that required by the line support. So here are some property that required. The first one, that is light in weight. So our first property, that is light in weight. So line supporters should be light in weight so that this can be transported easily, okay, with reduce in cost. So if the weight is less, then we can easily transport our transmission tower. Second, that is the strength. So line support should be strong so that they can take a weight of conductor in normal circumstances. It is more important that the line support can withstand in force of wind and storm. So whenever there is a bad weather condition, let's say stormy condition or high wind condition, at that time the strength of tower should be sufficient to withstand. Next, third one, that is the long life. So the life of the line support should be long so that they can give service for long period of time. So we do not need to change it or maintain it. Okay. Next one, that is economical. So the cost of the line support should be not high, because if the cost of line support is high, then our overall transmission cost is going to be increased, which is going to affect the cost of electricity, right? So next is accessibility. So the line support should be easily accessible for painting. It should always also be easy in installation of insulator and cross arm. So accessibility should be very good. Okay, so these are the properties of the material. Then after the reduce in maintenance, so maintenance should be very much of less. The line support should be such that the maintenance required is very less. And good appearance, it means appearance of the line support should be good, especially in the distribution line of the city, because it is going to change the look, or we can say change the appearance of that city. Then over here we are going to see the types of line support. So normally we are dealing with the three different types, that are the wooden. In wooden we have single pole wooden, that is A type, and H type. In wooden pole we have two different types, that is three different type I can say. First one, that is the single pole wooden, second one, that is A type, and third one, that is H type. So in steel type we have rail pole and tubular pole, okay, and in RC we have third one, that is the RCC pole. And fourth one, that is one important, that is lacide steel tower. So lacide is nothing but the it is the combination of truss of different steels. Okay, so it have total two types, that is narrow based lattice steel mast and broad based tower. Okay, so we are going to study all these in details. Okay, now starting with the wooden pole. Wooden pole are used in distribution system in the place where wood is easily in the price of wood. Okay, so price of the wood should be less in that portions. Okay, instead of RCC pole, normally we are using RCC pole, but if the availability of wood is very good and the property of wood is very good, then we can use our wooden pole. Now coating of bitumen is applied at the bottom of 0.5 meter to give the protection against moisture. Okay, so we need to protect our wood, because if we are not protecting our wood, it is going to be damaged, okay, due to the moisture portions. Now there are total three types of wooden pole that we already seen. That is first one, that is single pole structure. So single pole structure is used for low voltage and high voltage distribution line. These are used for the line voltage of 11 kV. Okay, it is used up to 11 kV, we can say. This can be used for maximum span of 50 meters. So distance between two tower, that is maximum 50 meters. Okay, and steel cross arm are fitted on the pole over which the insulator are placed. So insulator are placed on the steel cross arm. Okay, next one, that is A type and H type structure. A type and H type, as its name suggests, actually the shape of the tower is looking like A, and the second one, that is looking like H. So we are going to see the figure also. Okay, so the good transverse strength is obtained in this type of structure, because mechanical strength of this type of structure is going to be increased. These are employed for the span length between 60 to 75 meters, and this can be used for the line voltage of 11 kV and more. All these type of wood pole structure are shown in figure. So let's see the figure. Over here, this is the single pole, that is the A type. Over here, this is the A type, so it is going to look like a giant A, and the last one, that is the H type, because it is going to look like this. This is the H one. Okay, this is H type. So these three are the wooden pole. Okay, over here we have metal cap, and this is the steel cross arm, and on the steel cross arm we are going to provide our insulator over here and here. Same in the A type also, this is the steel cross arm. This both are steel cross arm, and an insulator are provided over here and fitted on the cross arms. And in the H type also we have these of the cross arms, that is made of steel, and insulator are provided on the end of that cross arms. Okay, now disadvantage and limitations. So the following are the disadvantage of the wooden pole. The first one, that is its life is only 20 to 25 years. Okay, so life is less as compared to other types of poles. Okay, second one, that is these are liable to root due to the terminals and moisture. So due to the moistures, because its feet are grounded, so the moisture are come into contact with that wood, and it is going to damage our wood. So its life, overall life, is going to be reduced, and it required frequent maintenance. Okay, that is the third one disadvantage of this type of material. Okay, now the disadvantage and limitation. So the following are the disadvantage of the wooden pole. Its life is only, okay, this is we already know about it, and moisture, this is also know about it, and the frequent maintenance. And fourth one, that is the mechanical strength is very less, and fifth one, that is these are not useful about 20 kV. Okay, about 20 kV we are not going to use wooden. Okay, so these are used only for the distribution system, we are not using it in transmission. Okay, remember that we are using only it in a distribution and cannot be used in transmission system, now next one, that is the steel pole. Okay, so we are going to steel pole are used for the distribution line and street lighting in city. Now its life is longer than the wood pole and has a pleasing appearance. Okay, pleasing appearance, it have pleasing appearance because it is look better than the wooden pole. It required reduced maintenance because maintenance is very less as compared to wooden in steel, and there is no problem of rooting due to the terminals, but there is a problem of rusting. Okay, in steel we have the problem of rusting due to the moistures. Okay, rusting due to the moisture. So it is painted or galvanized. We need to paint our steel or galvanized to prevent the rustings. Okay, to prevent from rusting we need to paint it in frequent manner. Okay, a base plate is provided at a base to erect in the ground, and the length of the pole is nearby 7 to 10 meters, that is 1 by 6 of its length. Okay, and 1 by 6 of its length of the pole is 0.2 meter length above the ground level, and we are going to dig it into the foundations. Okay, and here are two types, that is rail pole type and tubular pole types. Okay, now next one, that is oily railway tracks or steel poles, because we normally see the steel pole are eye shaped in rail tracks. Okay, I think you have normally seen that tubular steel pole, at a site of railway stations. Okay, in tubular pole, hollow round steel pipe are used. Its diameter is 3 to 4 steps over the lands. Okay, it is broad at the lower portion and narrow at the top, or we can say it is broad at lower side and narrow at the top side. Okay, so this is called tubular pole. This is shown in figure, and steel pole can be used for street lighting and bending the upper portions. Now we are going to see the RCC pole. So due to the unavailability of wood pole and increasing the cost of the steel poles, because cost is very costly and rusting problem is still there, and in wood moisture problem is still there, so we are going to use the RCC pole or pre-stressed concrete pole are become more popular. Okay, its mechanical strength is more and is used for more span length, because span can be increased because the mechanical strength of that pole is very high. It does not require maintenance as required in wood pole and steel pole. It is used in low voltage and high voltage both the distribution lines. Okay, main difficulty of it RCC pole is increase in weight, because the weight of RCC pole is very high, so we need to transmit it from one place to another place, that is with little bit of complex system, which increase the cost of transportation also. And so mostly these poles are fabricated near the site. These poles are fabricated near the site, so whenever we are going to install it, we are fabricated it near the sites. And H type structure can also be made with the RCC pole, and distribution transformer can be placed on over it is. Okay, and sketch showing the construction of RCC pole. So let's see the figure first. So here is the figure. This is the RCC pole. We have foundation first of all, and then under the foundation we have put our RCC pole, and this is the cross arm made of steels, and again insulator are provided at the end of the cross arms. Now lacided steel tower, and in this tower, like say the wooden RCC and steel pole are not used for high voltage transmission line. Okay, not used for the high voltage transmission line, and for the increase in span. So if we are going to increase in span, we need to introduce the lassite steel tower. So lassite steel tower structure are used for this. These structure are used for the line voltage of 66 kV or more. This structure is assembled at the site by bowing various part, or the whole structure is made near to it, or we can say 3 to 4 sections different and assemble on the site where we are going to establish it. Okay, so the earth wire is run over the tower, so there is no problem of protection against the lightning stroke. Okay, so earth wire is going to protect us against the lightning stroke, and pole are earthed at the center at regular intervals. Okay, we are earthed our poles at a certain regular intervals, and painting is done to give the protection against rusting. So let's see the figure. Here is the figure of that pole. This is the narrow base lassite steel tower. Okay, over here we have, this is the cross arm, one cross arm, this is second cross arm, and this is third cross arm. These are the suspension type insulator, and over here we are going to connect our conductors. Over here we are going to connect our line conductors, and on the top of that transmission tower, we can say the earth wire is run, which is going to protect us against the lightning strokes. So the mechanical strength of such structure is very high. It is designed for withstand the severest wind and cyclones. Okay, it is also going to withstand on the cyclones also. And there are two types of lassite type structure, that is narrow based and broad based. Okay, so in narrow based lassite steel structure, base is very much of narrow, that we seen in previous figure. It is used normally for the line voltage up to 132 kV and less, and the span is less with this broad, with respect to the broad base tower. Okay, so the span is lesser in narrow and wider in broad. Okay, in broad base tower the base is broad and all the four footing are concreted. Okay, it is used for the line voltage of 220 kV and more, because the voltage level we can increase it, and the span we can also increase it. So the construction of broad base steel tower is shown in figure. Let's see the figure. And here is the broad base. This is the second one, is the broad base. So the base is very much of broad, and here is the tower. This is the suspension type insulator. Over here we are going to connect our live conductors, and we have two earth wire over here running, two earth wire, and in this figure we can also see the two earth wire over here, and these are the two channels. Over here single phase, that is RYB, and over here second channel RYB, and this is the single channel, that is RY and B. So we can either connect as a and either connect as a B. So this is the broad base tower. Okay, now we have the comparison of the line support, that is this is the base value where whatever the parameter we are going to compare over here: wooden pole, steel pole, RCC, and lacite, that is narrow base and broad base. So voltage level we have given 11 kV in the wooden, 33 kV in steel, and 22 kV in RCC. Now for the narrow base it is 132 kV, up to 132 we can say, and for the broad base it is increased or more than 132 kV. Span is 50 meter for the wooden, it is going to be 60 to 75 for the steel, and 50 to 70 for the RCC, and span is more and large in broad. Okay, now cost: wooden is very much of less, steel is more, and RCC is relatively less, and narrow base is more, and broad base is highest because it is more mechanically stable. Now life of the wooden is very much of less, that is called as minimum, and steel pole is more, RCC also more, and lacite also more. Maintenance: wooden more, in steel we have less maintenance, in RCC we have minimum maintenance, and in narrow base we have less maintenance, and broad base we have narrow maintenance. And here are the applications, that is the low voltage distribution, low voltage and high voltage distribution, that is for the steel, and for RCC low and high voltage, and of lesser type only we are going to use it in transmission, not in distribution. Okay, so this is the comparison between these all the poles. Now loading on the transmission line conductor: while designing an overhead line, from mechanical point of view they are made to withstand worst probable weather condition. Okay, they are made to withstand the worst probable condition, because our mechanical strength need to be very much of high. This is desirable to have economical use of material at a risk of some severe condition which may rarely occur, okay. The loading on the transmission line conductors are: first one, that is the weight of the conductor; second one, that is the ice or snow on the conductor, this increase the weight of the line and projected area also. Okay, and the third one, that is the high cross sectional wind area, so wind pressure is also there on the conductor, and they cause additional effect on the load in the horizontal direction also. So in India, most of the area there is no problem of ice loading, we have no problem of ice loading, but except the Jammu and Kashmir, Ladakh, Himachal Pradesh, Sikkim. Okay, let's see this: the area of Jammu, Kashmir, Ladakh, Himachal Pradesh, Sikkim, Arunachal Pradesh, where low temperature is accomplished by snow and wind, sag of the conductor tend to be increased due to the ice load and wind pressure. So sag is going to be increased in this type of situations. Now what is span, sag, and tension relation between these all? The part of the overhead line between the two constructive support is called as a span. So if we have one transmission tower over here, second one is here, then the distance between these two is called as a span. The horizontal distance between them is called as the span length. Okay, and when the conductor is placed in a straight line passing through the two tops of the point of the support, it is called as a tight conductor. So if we are going to connect our conductor like this, it is called as a tight conductor. But in normal practice, the line between two consecutive supports follow a curved path. Then the maximum vertical distance of the span of the overhead line between the tight conductor and sag the conductor is called as a sag. So we have the original conductor, or we can say practical conductor, is looking like this, and the difference between these two is called as a sag. This is called as a sag. Okay, let's see the figure and understand it. Over here, this is the supporter 1 and this is supporter 2, and this is the tight conductor. Okay, so from that tight conductor, this is the loose conductor which is sagging from that poles. Okay, so this is called as a sag, this is the ground clearance, and this is the span. Okay, we can easily understand this concept of span and sag with these figures. In overhead line, a conductor is strung between two supports. Okay, the conductor will have a value of ultimate tensile strength at which it will fail. The ultimate tensile strength depends upon the material of which it is made, and the tension on the conductor is always limited to its half of the strength. Okay, therefore the safety factor is 2 is provided. The tension in the conductor depends upon its diameter, the conductor between pole material of the conductor, the sag of the conductor, wind pressure, prevailing the temperature. Okay, these are the several conditions on which the tension of the conductor is going to be depends. And in no case the tension in the conductor is more than the ultimate strength of the conductor divided by the safety factor. Now our safety factor is 2 over here. Now necessity of sag. So why we required sag? Because if we are using the sag, we required more amount of material of the conductor, right? So when a conductor is supported between two consecutive poles, the conductor will have sag or dip due to its own weight. Okay, actually sag determines the minimum ground clearance, that is the minimum height of the conductor above the ground. As per Indian electricity rule, provide minimum clearance of the conductor from the ground for safe operation of the transmission line. So we have some of the IS standards. Okay, thus the knowledge of sag for the line of different voltage is necessary to comply with the rules. Okay, so we need to be aware of which type of sag, or we can say what is the minimum value of ground clearance for which type of sag at what voltage level. So the value of sag depend upon the tension is increased. However, the conductor tension cannot be made very large, as if it is increased beyond design value, conductor may break in mechanical failure. Moreover, sag cannot be allowed to be very large also. Okay, so a larger sag required taller tower with the longer cross arms, okay, to prevent the swagging and clashing of the conductor. So conductor can be clashing with each other. Okay, so we require larger cross arms and conductor during the stormy condition. In the conclusion, it is concluded that the larger sag make the line more expensive because we require more materials for the transmission tower also, insulation material also, cross arms also. Okay, now the normal span used in India, that is given in the table, that is this is the voltage level, and over here this is the span. So we can refer out from here what is the voltage level and what is the span in meter. Now here is the ground clearance. So the clearance from the ground is also very important term. So for any transmission line, it is necessary to maintain a clearance from the lowest point of the conductor to the ground for the safeguarding of the life. The distance of the distance to be kept depend on the voltage level of the transmission line and be situated, or we can say be the situation of the line, that is whether it is crossing the main roads or passing by the buildings and it is passing by the farms or whatever. Okay, so the minimum clearance of the ground should be calculated from this table. So over here we have the value, that is the voltage, that is less than 650 to 325. At that time we can use 5.8, less than 66 kV we can use 6, between 66 to 110 kV we can use 6.4, that is in meter. Okay, and over here above 166 kV we can use the 7 meters. Okay, this is the minimum clearance. Okay, remember that this is not the maximum value, this is the minimum, we need to keep it anyhow. Okay, and here are some questions from GTU examination that can that we already covered in this video lecture. So explain mechanical design of transmission line and what are the properties of the line supports, and different types we need to explain, sagging explaining, and then after the loading on the lines in details. Okay, and that's it for this video. Thank you. If you find any kind of query, then ask me in comment section. Thank you.